In this video, we're going to start the KutaSoftware free worksheet under Infinite Algebra 1 using trigonometry to find angle measures. Our directions for numbers 1 through 6 are to find each angle measure to the nearest degree. For number 1, we have the tangent of angle A, so the tangent of A is equal to 2.0503. So since we're finding the angle measure to the nearest degree, we're going to have to isolate this A, because that's the angle. So in order to do that, we need to find a way to essentially counteract or cancel out this tangent. So if we take the inverse tangent or the arctangent of the tangent of A, whatever we do to the left, we do to the right. So we're going to take the inverse tangent or the arctan of 2.0503. So taking the inverse tangent of the tangent of A will leave us with just A on the left. And we'll enter this into the calculator. If you have a calculator handy, you can enter that in. Or you can just go to Google Calculator. And we're doing the inverse tan. But before we do that, make sure your calculator is set to degree mode, not radians, since we're finding the angle to the nearest degree. And we're going to do the arctangent, which is the inverse. So click the inverse, so the arctan, and we're going to type in 2.0503. That's going to give us 63.999, which will round to 64 degrees. So the measure of angle A is approximately 64 degrees. Let's go on to number 2. Just as we use the inverse of tangent, we can also use the inverse of the cosine to isolate this variable z, which is our angle. So the inverse cosine of the cosine of z, whatever we do to the left, we do to the right. So we're going to take the inverse cosine of 0.1219. We'll be left with z on the left, and that's going to be equal to inverse cosine of 0.1219 will give us 82.99, which rounds to 83 degrees. So the measure of angle z is 83 degrees. In number 3, we have the tangent of y is equal to 0.6494. We're going to take the inverse tangent of both sides. So the inverse tangent of the tangent of y is simply y, and that's going to be equal to the inverse tangent of 0.6494, which gives us 32.999, which rounds to 33. So the measure of angle y is 33 degrees. And number 4, we have the sine of u equal to 0.8746. Just like with tangent and cosine, we're going to take the inverse sine in order to isolate the u. Whatever we do to the left, we do to the right, or vice versa if the sine was on the other side. We'll be left with u on the left, and then the inverse sine of 0.8746 will give us 60.99, which is 61 degrees. Number 5, we have the cosine of v is equal to 0.6820. So we're going to take the inverse cosine of the cosine of v, and we're going to take the inverse cosine of the 0.6820. We'll be left with v on the left-hand side of our equation, and that angle is going to be equal to the inverse cosine of 0.6820, which is 46.99, so 47 degrees. And the last problem in this grouping, number 6. We have the sine of c, so we're going to take the inverse sine. So the arcsine of the sine of c is going to be equal to the inverse sine of 0.2756. We'll be left with C on the left, and then we just have to enter the right side into our calculator. Inverse sine of 0.2756 will give us 15.99, which is approximately 16 degrees. Now for the rest of these problems, our directions are to find the measure of the indicated angle to the nearest degree. And we're going to find that angle using sine, cosine, and tangent. So we're going to use SO, CA, TOA to help us remember which function we're using. So in this first problem, number 7, we're trying to find the measure of this angle here. Let's just go ahead and call this x. So we're finding the measure of angle x, and we're given what's opposite x, and we're also given the hypotenuse. So we have our O and we have our H, our opposite and our hypotenuse. So let's go ahead and use sine. So we have the sine of x is equal to opposite, which is 51, over hypotenuse, which is 55. So we have the sine of x is equal to 51 over 55. But since we're solving for x, we're going to need to isolate that x. And in order to do so, we're going to use the same methods that we used in 1 through 6 with the inverse sine in order to find what that angle is equivalent to. So we're going to take the inverse sine of both sides. So that'll leave us with x on the left-hand side, which is the variable we're using to represent our angle, and making sure our calculator is in degree mode, we're going to type in the inverse sine of 51 divided by 55, and that's going to give us 68.01. So when we round that, we'll get 68 degrees for the measure of the angle x. Number 8, let's go ahead and use a different variable. This time, let's use A. So the angle we're trying to solve for is this angle A. We're giving the opposite, and we're also given the hypotenuse. So looking back, SOHCAHTOA, we're going to use sine again because we're given the opposite and the hypotenuse. So here's our O and H for opposite and hypotenuse. So we're going to have that sine of angle A is equal to the opposite side, which is 19, over the hypotenuse, which is 27. Then we're going to have to isolate this A. And in order to do so, we're going to do the arc sine, or the inverse sine. So the inverse sine of the sine of A is going to leave us with A on the left-hand side. And then we'll just type this into our calculator. The inverse sine of 19 over 27. That's going to leave us with 44.7, which rounds to 45 degrees for the measure of angle A in number 8. In number 9, let's go ahead and name this angle Y. Again, we're given the opposite side, and we're also given the hypotenuse, since the hypotenuse is always opposite the right angle. So we're going to use sine again. So the sine of y equals the opposite, which is 34, over the length of the hypotenuse, which is 55. Then we're going to take the inverse sine of the left-hand side, and whatever we do to the left, we need to do to the right. So we're going to take the inverse sine of the right side as well. The inverse sine of 34 over 55, making sure in parentheses, since we're taking the inverse sine of that quantity, and that's going to be equal to 38.18, which is approximately 38 degrees. So y equals 38 degrees. So the measure of the indicated angle is 38 degrees. I'll go ahead and do one more problem, problem number 10. So please remember to click that subscribe button and also go ahead and like this video. And in the next video, I'll do 8 more problems and then finish up with the last 8 in a third video. So this worksheet is going to be split into 3 separate videos. But for now, let's finish up with number 10. So we're looking at this angle. Let's call this angle x. And we're given the opposite of x, so the side that's opposite x, and we're also given the side that's opposite the right angle, so that's going to be the hypotenuse. Again, remembering SOHCAHTOA, we're giving the O and the H, so we're going to use sine. The sine of angle x is equal to the opposite, which is 14, over the hypotenuse, which is 24. Take the inverse sine of both sides. To get that x is equal to the inverse sine of 14 over 24, which is 35.6, which rounds to 36. So x is approximately 36 degrees. And as always, if you have any questions or you need a more in-depth explanation, go to my tutorial section or feel free to comment below. In this video, we're going to continue on with the Using Trigonometry to Find Angle Measures worksheet, and I'll leave a link to get to the KutaSoftware free worksheet in the description below. Currently, our directions are to find the measure of the indicated angle to the nearest degree. In this video, the second video of this worksheet, I'm going to do numbers 11 through 18, and in the final video, the third video, I'll do numbers 19 through 26. So before we start with number 11, I'm going to write a useful acronym or a useful saying to help you figure out whether you're going to use sine, cosine, or tangent. That's going to be SOHCAHTOA. So the sine of the angle equals the opposite over the hypotenuse. The cosine of the angle equals the adjacent side over the hypotenuse. And the tangent of the angle equals the opposite side over the adjacent side. So in this first one, let's call this angle x. So we're solving for the measure of that angle x. We're given what's opposite x, so the O, and we're also given what's adjacent to x. Because remember, adjacent is touching the angle, but it is not the hypotenuse. So we're given O and A. Looking at SOHCAHTOA with O and A, we're going to be using tangent. So we can say the tangent of that angle x is going to be equal to the opposite, which is 29, over the adjacent, which is 38. Our goal is to isolate this x so that we can find what it equals in degrees. In order to do that, we're going to have to take the inverse tangent of both sides. Since whatever we do to the left, we also must do to the right, and vice versa. So the inverse tangent of the tangent of x is just x. So now we have our x isolated. The right side, we're just going to enter that into a calculator, making sure our calculator is in degree mode. We're going to do the inverse tangent of 29 over 38. And that quantity, 29 divided by 38, is within parentheses. The arctan of 29 over 38 equals approximately 37 degrees. So the answer to number 11 is 37 degrees. Remember, we're rounding to the nearest degree. In number 12, let's go ahead and call this angle A. We're going to solve using tangent since we're given the opposite and we're given the adjacent. The only thing we're lacking is this hypotenuse. So the tangent of A is equal to the opposite side length, which is 8, over the adjacent side length, 20. Now we'll do the inverse tangent of both sides in order to isolate that A, or get that angle by itself. The inverse tangent of the tangent of A is just A, and then we'll do the inverse tangent of 8 divided by 20, which is 21.8, which rounds to 22 degrees. So our indicated angle in number 12 is approximately 22 degrees. In number 13, again, the only thing we're lacking is this hypotenuse, so we know we're going to use tangent. Let's go ahead and call this angle B. So the tangent of B is going to be equal to the opposite, which is 34, over the adjacent, which is 42. Taking the inverse tangent of both sides, we're left with B on the left-hand side, so that angle B is equal to the inverse tangent of 34 over 42. Typing that into our calculator, we're going to get approximately 39 degrees. So the measure of angle B, which is our indicated angle, is 39 degrees. On to number 14. Let's go ahead and call this angle Y. So for angle Y, we're given the hypotenuse, and we're also given the adjacent. So let's scroll back up to where we wrote SOHCAHTOA so we can see if we're given the hypotenuse, we're either going to use sine or cosine, but we're given the hypotenuse and the adjacent, so we're going to use cosine. So for number 14, the cosine of angle Y is equal to, remember, it's adjacent over hypotenuse, so that's going to be 52 over 56. Just as we did with sine and tangent, we're going to take the inverse cosine of the cosine of y in order to isolate that y. Whatever we do to the left, we're going to have to do to the right. So we have y on the left-hand side, and then we're going to have to do the inverse cosine of 52 over 56. And that's going to give us approximately 22 degrees. So the measure of the indicated angle is approximately 22 degrees. In number 15, let's go ahead and call this angle X. For this triangle, we're given the hypotenuse and we're also given the adjacent. So we're going to use cosine. The cosine of x equals the adjacent side length, which is 8, over the hypotenuse length, which is 17. Doing the inverse cosine of both sides will leave us with x on the left, and typing that into the calculator, inverse cosine of 8 over 17 is 61.9, which rounds to 62 degrees. For number 15. In number 16, let's go ahead and call this angle A. For this triangle, we're given the hypotenuse and we're given the adjacent side of that angle A. So again, we're going to use cosine. The cosine of angle A is equal to adjacent, which is 13, over the hypotenuse, which is 18. The inverse cosine of both sides will get A on the left, and the inverse cosine of 13 over 18 is going to give us 43.7, which rounds to 44 degrees. So the measure of angle A is equal to 44 degrees. In number 17, let's go ahead and call this angle R. For this triangle, we're given the side that's opposite R, and we're also given the side that's adjacent to R. So remembering SOHCAHTOA, we have O and A, so we're going to use tangent. The tangent of that angle R is equal to the opposite side length, 34, over the adjacent, which is 39. Using the inverse tan on both sides will give us that R is equal to the inverse tangent of 34 over 39, which is approximately 41 degrees. So the indicated angle measurement is 41 degrees. And on to the last problem in this video, number 18. And in the next video, remember, I'll go ahead and finish out this worksheet. Let's go ahead and call this angle X. We're solving for the measure in degrees of that angle X. We're given what's opposite X, which is 51. That's the opposite, and we're also given the hypotenuse, because remember, the hypotenuse is always directly across or directly opposite that right angle. So remembering SOHCAHTOA, we're going to use sine since we're given the O and the H. The sine of that angle X is equal to the opposite side length, which is 51, over the hypotenuse, which is 54. Taking the inverse sine of both sides is our next step. In doing so, we're left with X on the left-hand side, and entering into our calculator, the inverse sine of 51 divided by 54 is going to be 70.8, which rounds to 71 degrees for number 18. Go on to the next video where I'll do numbers 19 through numbers 26. Before you do that, remember to like this video and subscribe to my channel. In this video, we're going to finish out the Using Trigonometry to Find Angle Measures worksheet on KutaSoftware. I'll leave a link to this free worksheet in the description below. Currently, we're finding the measure of the indicated angle to the nearest degree. So for number 19, you can see the indicated angle is marked with a question mark, and we've been replacing that question mark with a variable. So let's go ahead and use the variable x for this first one. Go ahead, and if you haven't already, write out SOHCAHTOA. This will help us remember whether to use sine, cosine, or tangent when solving for the measure of that angle. So the measure of angle x is what we're solving for. We're given the side that is adjacent to x, and we're also given the hypotenuse, since the hypotenuse is always directly opposite the right angle. So we have our A for adjacent, our H for hypotenuse, so we're going to use cosine. The cosine of angle X is equal to the adjacent side length, which is 26, over the hypotenuse, which is 45. We need to isolate this X, so we're going to take the inverse cosine of both sides. The inverse cosine of the cosine of x is simply x, and then we're going to enter in the inverse cosine of 26 over 45, making sure our calculator is in degree mode, and that's going to give us 54.7, which rounds to 55 degrees for number 19. So that indicated angle is approximately 55 degrees. In number 20, let's go ahead and call this angle Z. We're given what's opposite Z, and we're given the hypotenuse of 19. So we're going to use sine. Opposite and hypotenuse, we're going to use sine. So the sine of that angle Z is equal to the opposite side length, which is 16, over the hypotenuse of 19. Taking the inverse sine of both sides will help us isolate that Z. We'll be left with Z on the left-hand side, and that's going to be equal to the inverse sine of 16 over 19. And that gives us approximately 57 degrees for number 20. In number 21, let's go ahead and call this angle X. We're given all the side lengths, so we're going to be able to choose. We're given what's opposite, we're given what's adjacent, and we're given the hypotenuse. So go ahead, use either sine, cosine, or tangent to solve for this. I'm going to go ahead and use tangent. So we have the tangent of X, so we're going to need to enter in the opposite, which is 76, and we're going to need to enter in the adjacent, which is 57. So the tangent of x equals opposite, which is 76, over 57. Doing the inverse tangent of both sides will give us that x is equal to the inverse tangent of 76 over 57, which is approximately 53 degrees. Let's go ahead and use another function to solve this. Let's use cosine. If we're using cosine, we're going to need to do adjacent over the hypotenuse. So the cosine of x equals 57 over 95. Taking the inverse cosine of both sides, we'll get that x is equal to the inverse cosine of 57 over 95, which indeed equals 53 degrees. So you can see that you can use tangent, cosine, and go ahead and feel free to try it with sine. For sine, you're going to use the opposite, which will be 76 over the hypotenuse of 95, and you indeed will get 53 degrees. For number 22, we're given all three sides again. We're solving for this angle. Let's go ahead and call this angle B. Since we didn't use sine in the previous, let's use it now. So the sine of B is going to be equal to the opposite, which is 72, over the hypotenuse, which is 75. Taking the inverse sine of both sides, we'll get that the measure of that angle B is equal to the inverse sine of 72 divided by 75, which is approximately 74 degrees. For number 22. And feel free to use cosine or tangent as well. In number 23, we have 33, 44, and 55. If we're looking at this angle, let's go ahead and call this angle R. I used sine in the previous one, so I'll go ahead and use cosine this time. When I'm using cosine, I need to use the adjacent side over the hypotenuse. Our hypotenuse is 55, and the adjacent side is going to be 33. So the cosine of R equals 33, which is the adjacent side length, over 55. Taking the inverse cosine of 33 divided by 55 will give us about 53 degrees for number 23. In number 24, we're given all three side lengths again. I use sine, then I use cosine, so let's go ahead and use tangent for number 24. If we're using tangent, the tangent of our angle, let's go ahead and call this angle A. The tangent of A, we're going to need to use the adjacent side and the opposite side. So that's everything excluding the hypotenuse. So we do not need to use this 97. So we're going to do TOA, so it's going to be opposite over adjacent. So our opposite side is 72 over our adjacent side, which is 65. The inverse tangent of the tangent of A is equal to the inverse tangent of 72 over 65, which is going to give us approximately 48 degrees. For number 25, let's go ahead and use sine again. We're looking at this angle here. Let's call that angle X. So the sine of X is equal to the opposite, which is 39, over the hypotenuse, which is 65. That's going to leave us with X equal to the inverse sine of 39 divided by 65, which gives us approximately 37 degrees. So 37 degrees is the measure of that indicated angle. And lastly, number 26. Let's go ahead and use cosine. Let's call this angle Y, and we're going to say the cosine of Y equals, remember, it's adjacent over hypotenuse. So the hypotenuse is always directly across from the right angle. And also another trick to figuring out what the hypotenuse is, especially when given all three sides, the hypotenuse is always the greatest side length. So 74 is greater than 70, and 74 is greater than 24, so that is the hypotenuse when dealing with a right triangle. So we know that 74 is our hypotenuse, and the adjacent is 24. So the inverse cosine of the cosine of y is equal to y, and the inverse cosine of 24 divided by 74, entering that into your calculator, we're going to get 71 degrees. So the answer to our last problem on this worksheet is 71 degrees. Remember to go ahead and like this video, and also please subscribe to my channel, that way you're updated when I release new videos. Also, if you have any questions, please feel free to comment below.